Welcome to this session of Atria conversations around issues emerging from articles written in the magazine. Today's discussion is around this very important issue of language and mathematics, their relationship. How does language, for example, influence the learning of mathematics? In what way are both important for human beings to acquire? And is there something to be said about language and maths being both languages, and what does it mean to say that? और हम इसके बारे में भी बात करेंगे कि इसके लिए कक्षा में क्या किया जा सकता है, किस तरह की दिक्कतें भाषा के बारे में बात करते, गणित के बारे में बात करते हैं, भाषा के कारण आती है. तो we will start with Arddhendu. Arddhendu is in Azim Premji Foundation for 11 years. He has worked as a maths resource person in Chhattisgarh, and बहुत सारी किताबें इन्होंने मैथमेटिक्स की लिखी हैं, कई लेख लिखे हैं, और ये अभी एक स्कूल के प्राचार्य भी हैं. तो उस सारे अनुभव के साथ गणित की कक्षा में और भाषा का उपयोग, इसके ऊपर वो अपने लेख के आधार पर अनुभव बांटेंगे. हमारे साथ दूसरी रिसोर्स पर्सन है निशा बुटोलिया. अभी अजीम प्रेमजी यूनिवर्सिटी में पढ़ाती हैं. वो सोशियोलॉजी और भाषा दोनों की शिक्षा के बारे में बातचीत करती हैं, और इन्होंने भी बहुत अलग अलग स्तर पे प्रशिक्षणों को कंसेप्चुलाइज किया है, लोगों को प्रशिक्षित किया है, और शिक्षा के बारे में काफ़ी समय से सोच रही हैं. आप दोनों का स्वागत है इस वेबिनार में. सो वी विल स्टार्ट विद अर्धेंदु. अर्धेंदु, आपके दिमाग में ये सवाल क्यों आया कि भाषा की क्या भूमिका है गणित में, या व्हाट इज दिस इशू ऑफ लैंग्वेज ऑफ मैथमेटिक्स?
सो गुड इवनिंग एवरीवन. आई थिंक आज जो डिस्कशन होगा उसमें हमारे लिए बहुत सारा गणित पढ़ाने को लेके सवाल क्रिएट होगा, जिसको लेके हम बेहतर क्लासरूम का जो इंटरेक्शन है वो बेहतर कर सकते हैं. जो सवाल है कि हम भाषा में गणित में लैंग्वेज की क्या जरूरत है, और ऐसा ये आर्टिकल लिखने के पीछे मेरा थॉट क्या था. आप सब जानते हैं कि लॉकडाउन के दौरान जब लॉकडाउन हुआ था तो हमारे पास कोई ऑप्शन नहीं था जो बच्चे के साथ एजुकेशन को कंटिन्यू करने के लिए, टीचिंग लर्निंग प्रोसेस को बच्चे के साथ कंटिन्यू करने के लिए ऑप्शन नहीं था. तो यहाँ पर मैं धमतरी, छत्तीसगढ़ राज्य में धमतरी एक जिला है, उस स्कूल में काम करता हूँ. तो उस दौरान हमारे पास जो संसाधन था, जो रिसोर्सेस था बच्चे के पास, उसके आधार पर एक ऑप्शन था हमारे पास कि हम बच्चे के साथ कैसे मोबाइल के थ्रू में इंटरेक्शन कर सकते हैं. और वो मोबाइल जो है स्मार्टफोन नहीं था, स्मार्टफोन था लेकिन कनेक्टिविटी का दिक्कत की वजह से कॉन्फ्रेंस कॉल, आप यू कैन इंटरेक्ट विद देम थ्रू कॉन्फ्रेंस कॉल ओनली विदाउट एनी वीडियो चैट. सो इस तरह जो हम बच्चे से काम कर रहे थे, आप समझ सकते हैं कि जब हम रेगुलर क्लासरूम में पढ़ाते हैं बच्चे को, तो हमारे पास क्या क्या एलिमेंट्स मदद करता है एक टीचर के रूप में. तो मेरे हिसाब से 3 एलिमेंट्स रहता है. एक तो है कि हम ब्लैक बोर्ड का यूज करते हैं, बोर्ड वर्क जो करते हैं वो एक विजुअलाइजेशन बच्चे को देता है. उसके साथ साथ हम जो वर्बल कम्युनिकेशन करते हैं, आप जो बोलते हैं, साउंड प्रोड्यूस करते हैं, तो एक तो हो गया विजुअल कम्युनिकेशन, दूसरा हो गया ऑडियो जो वर्बल कम्युनिकेशन, और थर्ड एक है जो जेस्चर बोलते हैं. जेस्चर इन द सेंस आप जब पढ़ाते हुए आप देखे होंगे बहुत सारा आपके हाव भाव से बच्चे समझ जाते हैं. तो ये 3 एलिमेंट्स जनरल क्लासरूम टीचिंग प्रोसेस में मदद करते हैं. So one is board work, that is helps in visualization. Second is verbal communication. Third is gesture. So all those 3 components helps in teaching mathematics in a regular class. But हम कंसिडर करेंगे जब ऑनलाइन में जो टेली कॉन्फ्रेंस के थ्रू में बात करना है, उस दौरान आपके पास वर्बल कम्युनिकेशन तो रहेगा लेकिन आपके पास बोर्ड वर्क नहीं रहेगा, क्योंकि आप क्या लिख रहे हैं, बच्चा क्या भी देख पा रहा है, ये नहीं ऑप्शन है. दूसरा है कि आप जेस्चर भी नहीं बता सकते हैं. आप जब फोन पे बात करते हैं, आप क्या जेस्चर के साथ बात करते हैं वो समझ में नहीं आता। तो हम जब इसमें बच्चे के साथ काम कर रहे थे, 6, 7, 8 की बात करता हूँ, तो गणित में जब बात कर रहे थे तो बहुत सारा समस्या आया है। जैसे मैं एक छोटा सा एग्जांपल दे रहा हूँ आपको कि मैं सपोज बोलता हूँ कि 2x+3/5 इज इक्वल टू 3। और एक बार मैं रिपीट कर रहा हूँ आपको समझने के लिए। पीपीटी चला सकते हैं तो बेहतर होगा, उनको सवाल क्लियरली दिख सकता है, अदरवाइज मैं एक्सप्लेन कर रहा हूँ। 2x+3 डिवाइडेड बाय 5 इज इक्वल टू 3। सो मैंने जब इस सवाल को बच्चे को बोला कि ये इक्वेशन को आप हल करो, तो थोड़ी देर के बाद मैंने उनका जो आंसर आया, बहुत वेराइटी आंसर आया बच्चे का। तो जब बाद में चर्चा किए, बच्चे ने करके आए नेक्स्ट डे, तो बात किए, तो उसमें पता चला कि एक बड़ा प्रॉब्लम जो था, क्वेश्चन लिखने में भी बच्चा गलती किया। जैसे कुछ बच्चे क्या किए थे ना, 2x+3 होल डिवाइडेड बाय 5 इक्वल टू 3 लिखे थे, एंड सम स्टूडेंट राइट इट एज 2x+5 डिवाइडेड बाय 3 5/3 equal to 3. So they when I verbally communicate the question, na, they capture it or visualize it in two different ways. So in this that is the only one problem. That is only one problem. Another problem is that suppose in solving algebra, when you're dividing the algebraic expressions, we have to explain them step by step process. First divide this way, and then subtract, then check the remainder. Then so there is lots of step by step process need to be communicated to students. So the question was how to communicate. Can I communicate through mobile calls or not? So that time I was totally disappointed in the sense, because students were very उनको बहुत अच्छा नहीं लग रहा था कि क्लास क्या हो रहा है, समझ में नहीं आ रहा है, क्लास चल रहा है। तो उसके बाद मेरे मन में सवाल आया, क्लास तो हमने किए, मैनेज इन द सेंस we refer the textbook page number and example number to explain, to reduce the problem up to certain level. I'm saying that we have not reduced the problem totally, but we try to reduce the problem by referring the specific page number, specific example of the textbook. But that was not sufficient in case of mathematics. Imagine how to do mathematics through teleconference. Language, in case of language, that may be possible up to certain level, but science, maths, geography, some portion of geography, that is very difficult. So that's created a question for me, that is there any verbal communication exist in mathematics through which you can communicate student properly without any ambiguity? Because I had not that idea. Because we are taught in the similar fashion, there was no problem during that time, because in our schooling, visualization was there, verbal communication was there, gesture was there. But in case of online teaching, only verbal communication was there. So that's create in a mind that I can write something about this. It is not limited to online classroom. Also in regular classroom, also sometimes you use improper mathematical language. That's also created problem. So I thought the total community in the sense, all the teachers, research person, everyone who is working in this sector, they can think and create some better language, or they can make debates on it, so that we can learn something and use it in our classroom teaching process, so that it will be benefit for our students. So that was my mind during that time.
Thank you, Arddhendu. So basically, what I understand from what you said is that when you teach mathematics, apart from the words, there are many things that you use. And for that, you use Blackboard. You can use your expressions and your gestures. You can also use objects and things. And in a communication which is through a telephone, that kind of a thing is not feasible. तो आपको लगता है कि ये सवाल इम्पोर्टेंट है कि अगर सिर्फ शब्द हों तो गणित पढ़ाने में जो चीज़ें हैं उसको पढ़ाने में थोड़ी मुश्किल आ सकती है, और इसीलिए बहुत ज़रूरी है कि जो क्लासरूम्स हैं उसमें फेस टू फेस इंटरेक्शन जिसके बारे में हम बात करते हैं, और उसमें कुछ साधन साथ में हूँ, जिससे कि आप वो सब चीज़ों की मदद ले सकें जो मैथ्स के कॉन्सेप्ट है उसके बारे में बात करने के लिए. दिस इज व्हाट आई अंडरस्टूड फ्रॉम व्हाट यू सेड. The question then, in terms of thinking about language or mathematics and or kind of things that you can use in mathematics, what is it that you think are important? I mean, you did mention something about how the equation looks. You may also think in terms of some diagrams or figures, but what all do you think is included in the language that you use to express mathematics?
Okay. So when we are talking about language of mathematics, for me, my understanding is that language of math includes some elements such as in mathematics, we use some terms. So, for example, difference, factors, limit, mean, operations. Some of the terminology used in mathematics are specific to mathematics, and some are generic. Generic in the sense that those are also used in natural language. Like I will say product. So the meaning of product in natural language is different from the meaning of the product in mathematics. So use some terminology in mathematics. That is one part of language. Second is symbol. There are specific symbols used in mathematics, like 1, 2, 3, 4 type, or percentage, pi, elements, belongs to, for all. So these are the specific symbols used in mathematics. Third is diagram, because diagram is also one major part of language of mathematics. Suppose we are explaining about square. So how will we express? One way is to write in in the text everything, or one is use of diagram. So we use diagram to represent integrations, graphs, geometrical shapes. So third part is diagram. Fourth is like you use generally says now the angle, positive angle, negative angle. There is some direction in that. So conventions are used. In word mass, you start from multiplication, then division, multiplication, addition, subtraction. There is some convention in it. And another one is statement or statements and expressions. So all those things combined together forms mathematical language. So how mathematical language, in the sense it helps in exploring mathematical ideas, also communicating mathematical ideas. So all those things like terminology, symbols, diagrams, conventions, statement and expression, all those things together forms mathematical language. And you just imagine, suppose all these things are removed from mathematics, then we don't have nothing to say about mathematics. So that's why in mathematics, we need everything in a proper way. And we should use all those things in a mathematical structure, within mathematical structure, so that student can understand, explore the concept well. So for me, mathematical language means all those things. All together forms mathematical language. I will not say single part. In expression, you have to use symbols, operations, everything. You have to explain concept, you have to use statements, diagrams, everything. So all those things combinations together forms mathematical language. So one thing which is important is that how mathematical language is important in mathematics. So mathematical language helps in, suppose you are using proper mathematical language, diagrams, symbols, statement, expression, with verbal communications also, proper verbal communications, then it helps students in developing mathematical proficiency. Mathematical proficiency in the sense, all total mathematical understanding. In the sense, a student can develop conceptual understanding very well, procedural fluency very well, adaptive reasoning very well, productive disposition very well, strategic competency very well. So all those, whatever mentioned in the NCF, National Curriculum from 2005, everything is covered in this. That if you are using proper mathematical language, the students can develop mathematical proficiency well. So if I'll say some examples, I'm taking an example from class 7. In Chhattisgarh textbook, we are using state textbooks. So generally, we all majorly we are using similar language. Like yeah. So you can see the statements here, expressions. One is 12 and symbol, then 5. Another is 12, a symbol, then within the bracket there is symbol and 5. I'll read that. I'll read the first one as 12 minus 5. Generally, we read it differently in the different teacher use it differently. Like 12 minus 5, something. Some teachers say that subtract 5 from 12. So here in both the cases, in both the expressions, you can find the same symbol used in both the expressions. But the first one we called as 12 minus 5, and the second one generally there are two ways we communicate. We can if you can run the PPT now, just click once more. So you can see that the second one, one second, we read it as 12 minus 5. It is my observation is that I am also using this. Sometimes I am trying to avoid, because in our schooling also our teachers taught us in that way. So we used it in that way. But the question is that in mathematics, the symbols used in different places or different contexts have different meaning. Suppose in this case, when the minus sign is, I'm not use the minus sign, the sign which is we are indicating now, if it is used in the middle place, that means it is an operation. We are operating 12 minus 5, or we are subtracting 5 from 12. But in the second expression, it is 12 minus, but can you read it as minus 5, 12 minus 5? Mathematically, I think, as a language of math, in the frame of language of mathematics, I think we should not say that 12 minus 5, because we have read integers and there is a special symbol used to show opposite sign of a number. So how to read? We use negative numbers. Suppose 5, then the negative will be negative 5, not minus 5. Minus is an operation, and negative is the opposite sign of a number. So generally we used, and how we solve the problem? Generally we say that 12 minus 5, and minus is plus. So 12, the result will be 12 plus 5, and the result will be 17. So here, the same symbol is in different place, but the meaning is different. So we need to understand the specific mathematical language. When you use something in, like in the decimal, if you observe in the decimal number, you use the decimal point below the number, between the numbers, but in the lower side. However, in the multiplication case, dot product case, you use the same symbol, but in the middle of the position will be middle. So this is the specific things we need to take care. हम जब गणित पढ़ाते हैं, एक ही सिंबल अलग अलग जगह में यूज होता है तो उसका मतलब बदलता है और उसका बोलने के तरीके भी बदलता है और मैथमेटिकली लॉजिकली वो अलग हो जाता है. इसको बहुत ध्यान देना चाहिए, क्योंकि बच्चे जब इस सवाल को बोलते हैं ना 12 So 12 minus 5 is 12 plus 5. We say that minus and minus is plus, which is mathematically, from my understanding, it is wrong. We cannot operate two operations. We are operating two operations, minus and minus. We say minus into minus is plus. So how we can operate two sign? We have to operate two numbers. So how logically we can develop? I think. So could you please move to the next slide? Yeah. So mathematical language say that we should read it as 12 minus negative 5. So we are subtracting 12. Sorry, we are subtracting negative 5 from positive 12. So how it is possible? The mathematical property, as you know, that in the mathematical proficiency, we have discussed regarding the term reasoning, adaptive reasoning, logical reasoning. In mathematics, generally we should use every step. In every step, we should mention the reason, logic, property. What are the why we are using some term? So we have the condition that just play one step, just one. So we know that suppose I am saying that a minus b, that means a minus b means, sorry, just, yeah, it is not there, I think. So, okay, just a second. Yeah. So when I am saying that a minus b, what does it mean mathematically? It means we are adding, that means a plus additive inverse of b. Suppose a minus b, we can say that a plus additive inverse of b. So in this case, when you are subtracting minus negative 5, sorry, it's come to my mind minus, because I am habituated of using during my schooling also. So we are subtracting negative 5 from 12. So as per the mathematical logic, it is 12 plus additive inverse of 5, additive inverse of minus 5. So what is additive inverse of minus 5? Plus 5. So the result will be 12 plus 5. The result is 17. So in the general course, we say that minus and minus is plus, so 12 plus 5 plus 17. The result will be same. But the logic and the concept we want to develop is not the same as shared in this slide. So I think language is important, and the expectation of our mathematics from our mathematics now is not to get the answer at any way. We have to develop, we have to understand, we have to explore the logic, arguments, mathematical thinking also. So this is one example where we miss the use of proper language, and that what should be the proper language and how to explain it is. And this expression, this explanation is in our class textbooks, in Chhattisgarh textbook. However, it may be difficult, but I don't think that it will be difficult in the sense if you are not practicing something, it will be difficult. But if the child has the ability to do and we are providing space to explore, then I think they can do it. Thank you.
Thank you, Arddhendu. Can we, Shanaz, can we go back to slide 8? I want to just kind of summarize what Arddhendu has said. Slide 8, please. 8. Go back. Go back. Further back. Yeah, this one. Right. That's right. That one. The first one, Shanaz, before this. Yeah. So when we think in terms of the ideas of mathematics, I think what Arddhendu said was that जब हम गणित में भाषा की बात करते हैं तो कई सारी चीज़ों की हम बात करते हैं. हम बात करते हैं कुछ हमारे कन्वेंशन हैं, कुछ एक्सप्रेशंस हैं जो हम लिखते हैं, कुछ सिंबल्स हैं जिनके बारे में वो अभी बात कर रहा था, और वो सिंबल्स कैसे अलग अलग संदर्भों में उनको समझना पड़ता है कि कैसे उनको इंटरप्रेट किया जाए. डायग्राम्स के बारे में उन्होंने बात की, ग्राफ्स होते हैं, फिर ट्रायंगल्स, रेक्टेंगल्स, कंस्ट्रक्शंस होती हैं, वो सब होता है. तो जब हम गणित के बारे में बातचीत करते हैं कक्षा में तो कई चीज़ों का ध्यान रखना पड़ता है. प्लेसमेंट और सिंबल्स की एक बात है, फिर स्टेटमेंट जो एक्सप्रेशंस का है वो कैसे लिखी आपने, और फिर उन्होंने एक बहुत अच्छे एग्जाम्पल से बताया कि हम किस तरह से शब्दों का इस्तेमाल करते हैं. कि हालांकि -5 कहने से हम सब उसको मान लेते हैं कि 5 जोड़ना है, बट एक्चुअली इट शुड बी -5, so that you are then suggesting to the learner कि आप -5 के एडिटिव इन्वर्स पे काम कर रहे हो. तो उससे फिर आप ये समझ सकते हो कि आपको एक्चुअली 5 जोड़ना है, बिकॉज यू आर वर्किंग ऑन दी एडिटिव इनवर्स ऑफ -5. I think this is very important to recognize that language, both in terms of symbols that you use, the placement of the symbols, and then the consistency of the use of language, of the symbols, as well as the kind of words we use in explaining concepts, it is very important. So while it is all right after you've learned the concept to use terms like minus minus 5, 12 minus minus 5 is equal to 17, but the child must in her mind also be able to recognize that 12 minus negative 5 is what is being talked about. So I think these are basically among many things which Arddhendu has said. I don't want to summarize all of it, but I think the point about the fact that there are many aspects in which you use symbols, expressions, which are all in some say ways language into talking about mathematics. So I will now go to Nisha and I will take on from where Arddhendu has left us. People talk about mathematics is also a language. What is your view on it? I mean, is that a good way to say it? What is the similarity? What is the difference between the two? Would you call mathematics a language, or and how would you describe it?
So, you see, I think that in language, what we are doing is we are communicating the thoughts. Now, in mathematics, also, we are communicating thoughts, but the thoughts are different. These are mathematical thoughts conveyed through the symbols, through other abstract operations, and so on. So basically, I see that there is a lot of similarity between mathematics and language, because both the areas, I think also there is a lot of overlap between language and mathematics, because ultimately what you are trying to do is working with the symbols, but the final aim is to also communicate the complete mathematical thinking through the symbols and operation to the audience or to the self. So there is this element of communication in both language and in mathematics. But in case of language, we know that we are working with a lot of words which we have used already, and there is a lot of real experiences that we share, or even the abstract ideas get shared through language. So similarly with maths. Similarly, if you look at the symbols that we use in the script are abstract symbols, and the child who is learning to use a script has to learn those symbols. But in case of language, when once you have mastered those symbols, it ends up in giving you a word which is very meaningful, in the sense you have used it in your oral language. So that sort of provides it kind of a concrete shape to the words. But in case of mathematics, as Arddhendu has explained, it is a play of symbols, completely abstract. So that I think is also a difference between the two. But largely, if you look at how even mathematics in the beginning years, concepts are formed in mathematics, it's also through the lot of concrete experiences. And we know that the children who are coming from the language backgrounds which are different from the medium of instruction in school, those children struggle a lot. It itself is a proof that, if your mathematics class is happening in English and children are not able to understand English, they will hardly understand anything in maths. So it's not just that it is maths is about symbols and diagrams and representations, which it is to a large extent, but it is also about this holistic communication, uh, a kind of a narrative that gets formed because you are working with the symbols, right? You start with a problem, then you logically deduce it, and there is an interrelationship between each of the stages, and those interrelationships are actually the points of where the language intervenes. For example, you say, therefore we conclude this, that is why maybe it is like this, or suppose that x value of this thing is x. So here what are you doing? You are through the language helping people to visualize. Without that, it is very difficult. So, though all of us know that language of mathematics is very abstract because of the reasons that Arddhendu has stated, there is a lot of abstraction even in case of using script for children. But the nature of the two things is different. I also want to say that in the initial years, when children are developing these concepts or using language, there is no bifurcation in terms of this is mathematical concept because I'm talking about small and big here, and this is a language concept. For example, if I say that pumpkin is bigger than an apple, then now it is futile exercise to ask whether it is from the language subject or EVS or from maths, because it's a social or a reality outside which is being expressed. So a lot of mathematics, at least in the initial years, can be developed when there is a lot of interaction with the environment, and same is the case with language and EVS. Like NCF 2005 says that all the learning at the primary stage is essentially language learning at the primary and the foundational stage.
So, मैं जो समझा हूँ, Nisha, I've been trying to please add to that, because what I understand you say is that mathematics में भी abstraction है, language में भी abstraction है. But the nature of abstraction in mathematics is more because there are less experiences and less concreteness in the words that we use in mathematics. Would you say that is correct? Yeah.
As we go further, Hardy, I said that as we enter into the disciplinary domains of mathematics and so on, then the subject specific registers come into place, and the students are expected to master those registers and use the language in specific manner. That is the aim of teaching a discipline. So that is, I'm saying, true. But at the foundation stage, what forms the foundation for such kind of engagement or such kind of visualization is the language abilities of people.
So, you also talked about a mathematical text, and I think Arddhendu spoke about a lot of expressions, and some of the examples that he wrote, that 12 minus 5, and or you can also talk about the fact that how do you use those symbols that are there in mathematics to construct a mathematical text. Now that mathematical text uses entirely mathematical symbols, and the student has to read both a mathematical text as well as a language text. तो अर्धेंदु, आपको क्या लगता है, एक जैसे आप गणित की किताब पढ़ते हैं 10वीं में, तो उसमें कई बार एक पेज होता है जिसमें सिर्फ इक्वेशंस और एक्सप्रेशंस लिखे होते हैं, और उसके तुलना में एक पेज है जिसमें बहुत सारे शब्द हैं. तो उन दोनों को आप कैसे डिस्टिंग्विश करेंगे, क्योंकि मैथ्स में तो दोनों पढ़ना और समझने की ज़रूरत होती है. तो अगर आप भाषा और गणित के संबंध की बात करें, तो आप इन दोनों के फर्क को कैसे डिस्क्राइब करेंगे?
तो ये सच है कि हम जो मैथमेटिक्स बोलता है कि हमारा जो लैंग्वेज होता है वो बहुत प्रिसाइज और कंसाइज होता है. तो प्रिसाइज और कंसाइज का मायने यही होता है कि आप जो सिंबल ज्यादातर सिंबल की फ्रेम में रहता है, गणित के ही सिंबल रहते हैं. लेकिन गणित पढ़ाने के लिए गणित के सिंबल ही केवल काम में नहीं आता है, क्योंकि कॉन्सेप्चुअल और डेवलपमेंट, अंडरस्टैंडिंग डेवलपमेंट करने के लिए आपको तो शुरू जो करेंगे वो जनरल लैंग्वेज से शुरू करेंगे. उसमें मैथमेटिकल टर्म रहेंगे लेकिन जनरल लैंग्वेज से शुरू करेंगे. तो बच्चे को दोनों में कॉम्पिटेंसी डेवलप करना पड़ेगा. आप जब बात कर रहे होंगे, जो स्टेटमेंट लिख रहे होंगे, वो तो मैथमेटिकल कम्युनिकेशन तो कर रहा है, मैथमेटिकल आइडिया को कम्युनिकेट कर रहा है, लेकिन उसमें जो लैंग्वेज यूज हो रहा है वो सभी लैंग्वेज यूज हो रहा है. नेचुरल लैंग्वेज और मैथमेटिकल लैंग्वेज मिक्स होता है. तो मेरे हिसाब से हमको स्टार्टिंग में तो नेचुरल लैंग्वेज और मैथमेटिकल लैंग्वेज का जो कॉम्बिनेशन आता है, जो जेनरिक फॉर्म में आता है, उस पर बात करना चाहिए, और उसको आहिस्ता आहिस्ता एब्स्ट्रैक्ट में लेना है. एब्स्ट्रैक्ट में प्योरली मैथमेटिकल सिंबल में लेना चाहिए ताकि बच्चे समझ पाए. अदरवाइज मेरे हिसाब से कोई सिंबल डायरेक्ट मैथमेटिकल फ्रेम में लिख देंगे तो बच्चे तो बहुत कंफ्यूज होते हैं. तो हमको शुरू ऐसे करना पड़ेगा कि हम पहले नेचुरल लैंग्वेज आहिस्ता आहिस्ता उसमें से सिंबल को रिड्यूस करके, जैसे हम बच्चे को जब एडिशन पढ़ाते हैं, आई एम टेकिंग एन एग्जांपल फ्रॉम प्राइमरी लेवल, एडिशन जब पढ़ाते हैं हम बच्चे को 2 + 3 = 5 नहीं पढ़ाते. हम ये बोलते हैं there are three bars and 2 bars came to that group. So 2 bars and 3 bars is total 5 bars, or we use 2 bars and 3 bars forms 5 bars. Then you reduce the general language. You reduce the general language as 2 bars and 3 bars equal 5 bars. then we reduce the symbol and with plus 2 plus 3 equal to 5. So this is the step-by-step process when we reduce the natural language and mathematical combination of natural and mathematical language to pure mathematical language. And it's important because in mathematics now one pedagogy is that context dependent to context independent. Mathematics don't have any context. So but to teach mathematics you need context. So generally that's why you use context, and context can be explained or expressed through natural language. So use natural language, then reduce to mathematical symbol. Thank you.
अर्धेंदु एक मिनट रुकिए, ये आपने बहुत इंपॉर्टेंट बात कही है कि इसको थोड़ा एग्जाम्पल से समझाएंगे। आपने कहा दो बात, एक ही वाक्य में दो चीज कही। आपने कहा, एक तो ये कहा कि गणित संदर्भ रहित होता है ना, और दूसरी बात आपने ये कही कि लेकिन आप गणित को बगैर संदर्भ के पढ़ा नहीं सकते। ये मैं समझा आपकी बात से। तो इसको थोड़ा सा आप या निशा इसको थोड़ा सा समझाएंगे कि व्हाट डज इट मीन व्हेन यू से दैट यू कांट टीच मैथमेटिक्स विदाउट ए कॉन्टेक्स्ट, बट येट मैथमेटिक्स इज कॉन्टेक्स्ट फ्री।
अच्छा, मैं अपनी तरफ से कोशिश करती हूँ कि जो अर्धेंदु का एग्जाम्पल था, एक्चुअली द डिस्क्रिप्शन दैट ही हैज रिटन इन हिज आर्टिकल talks about how his presence, physical presence in the classroom was required because he was also using other resources, maybe diagrams, and the way he was maybe noting down on the blackboard was important to assist or scaffold students' understanding about a given equation. I also think that, and later also Arddhendu in his article has reflected that how important it is to pay attention to the words that we are using in any mathematical calculation also. So to begin with, I think the process of mathematical thinking begins with lot of context, because there are concrete experiences which can be then abstracted in the form of symbols and operations, etc. To begin with, but there has to be a lot of context. That is one part. And the second is, even when this is 12 minus -5 kind of an expression, though on the face of it looks just numbers and symbols, but when Arddhendu explained about it, there are a lot of words and there are other things that got added on how the person is thinking about this mathematical equation, and then how one arrives at the answer. So I think that a teacher's explanation to each of these statements, and then also the explanation of how and why we are going from one step to another, is also a sort of context that a mathematical equation requires. And it is not just, maybe at the surface level it may look like a simple play of symbols, but it is not so. Arddhendu can add to it.
Yeah, so मैं एक एग्जांपल दे रहा हूँ। जनरली मैथमेटिक्स को समझने के लिए जैसे कॉन्टेक्स्ट देना पड़ता है। आप कोई भी कॉन्सेप्ट उठा दीजिए, जैसे इंटीजर के बारे में बात कर रहे थे हम, तो उसी पे बात करते हैं। आप कैसे बच्चे को नेगेटिव संख्या को इंट्रोड्यूस करें, क्योंकि मैथमेटिक्स में जब लिखा हुआ है -2, ये -2 किसका है किसको पता नहीं, कोई कॉन्टेक्स्ट पता नहीं। ये टेम्परेचर के बारे में बात कर रहा है कि कोई लोन लिया था उसके बारे में बात कर रहा है, कुछ पता नहीं, बिकॉज इट्स प्योर एब्स्ट्रैक्ट। लेकिन जब हम इंट्रोड्यूस करते हैं बच्चे को एक ऑपोजिट डायरेक्शन के बारे में बात करते हैं, ऑपोजिट डायरेक्शन के क्वांटिटी के बारे में बात करते हैं, तो अब हमको कॉन्टेक्स्ट देना पड़ता है। जैसे हम बोलते हैं कि एक नंबर कुएं के बारे में बात करते हैं कि कुएं के ऊपर को हम सपोज एक कुछ मार्क किए हैं, वहां पर 2 मीटर ऊपर में है, तो नीचे कोई कुएं के नीचे कोई चीज है 2 मीटर नीचे, तो उसको कैसे बताएं? या आपने 2 रुपया आपके पास है तो उसको हम +2 बोलते हैं, जिसके पास 2 रुपया लोन किए हैं उसको क्या बोलेंगे आप? तो कॉन्टेक्स्ट देना पड़ेगा, क्योंकि विदाउट कॉन्टेक्स्ट में आप उसको विजुअलाइज नहीं कर पाएंगे। एक नए सिंबल को विजुअलाइज करेंगे कैसे? मेरे सामने आप सपोज एक बच्चा है, इंटीग्रेशन का मैंने चित्र बना लिया जो सिंबलिक फॉर्म लिख दिया, बच्चा क्या समझेगा? कुछ कॉन्टेक्स्ट नहीं है, कुछ पता नहीं है, तो समझ नहीं पाएगा। तो इसलिए मैथ्स में कॉन्टेक्स्ट देना ही जरूरी है कि आइडिया जनरेट कैसे होगा, एक बच्चे एक्सप्लोर कैसे करेगा, बच्चे एंगेज कैसे होगा। एक्सप्लोर एंगेज के बिना समझ नहीं बन सकता है। So that's why we need some context, and that context is reduced simultaneously, and then we reach to the abstract symbol. In fraction
Thank
also,
you.
yeah, please.
No, finish. Please complete your statement.
Yeah. Similarly, हम जब भिन्न या फ्रैक्शन पढ़ाते हैं, फ्रैक्शन का कॉन्सेप्ट पढ़ाते हैं, हमने कभी कभी जनरली ये मैथमेटिक्स में एक प्रॉब्लम है कि हम एब्स्ट्रैक्ट कॉन्सेप्ट को ना झगड़ते हैं कॉन्टेक्स्ट डाल के। जब लिखा हो 1/2, व्हाट डज इट मीन? सेव के आधा है कि घर के आधा है कि एक बकेट में कितना सामान है उसके आधा है, कुछ पता नहीं, एक्चुअली नहीं है कुछ, वो एब्स्ट्रैक्ट है। लेकिन एक बच्चा एब्स्ट्रैक्ट समझेगा कैसे, या एब्स्ट्रैक्ट चीज को ऑपरेट कैसे करेगा? जैसे हम बोलते हैं 1/2 + 1/3, तो बच्चे क्या करेगा, कैसे कॉन्टेक्स्ट? इधर उसको एल्गोरिथम याद करा दीजिए, एक तरीका है कि वो रट्टा याद करके चला देगा, या याद मतलब रोड लर्निंग करेगा। दूसरा ऑप्शन है कि वो समझे 1/2, व्हाट इज 1/2, व्हाट इज 1/3, when you are operating, when you are adding both these things, how you can operate. That's why we are taking LCM or equivalent fraction. So that's why I'm saying that context is always important in mathematics to relate with the real life situation. One thing which is important there, context is also important in the sense when we are using mathematics now, we are solving problems. So we need to connect with the context, because my understanding is that suppose some word problem is given, when I am not connecting with my real life situation, then till then I cannot solve it. So that's why context helps in understanding the concept. Also, context helps in solving the problem also. So both way. Thank you.
So this is what links to what Nisha was also saying about language, that if I am talking to students in English and they don't have a background in English, they probably cannot understand what I am saying. And therefore, the mathematics I teach will become very difficult for them. And I think, it's just about, you can extend the idea of language to the more, not just English and Hindi, but also shades of flavor of that community understands, the kind of objects, the kind of context, situations the children deal with. So what I understand from what you're saying, Arddhendu, is that if your classrooms are built around contexts and situations which children are familiar with, so if you're talking about fraction numbers, then if children deal with half a liter of milk, half a liter of oil, half a kilo of rice, or similar things, then talking about them using words like pav, pawn, 3/4, a quarter, and then getting them to work with them also would give them an understanding of how to deal with fractional numbers. So rather than just talk about 1/2, 1/4, 3/4, if they get linked to the experiences that they already have, then this is what would make it more meaningful for them. And शायद यही बात ये भी जब हम कहते हैं कि संदर्भ और बच्चे की संस्कृति के साथ जोड़ के हमें गणित को सिखाना चाहिए, शायद दिस इज व्हाट इज इम्प्लाइड इन दैट। द अदर थिंग जो आप कह रहे हैं वो भी बहुत मुझे लगता है ज़रूरी है कि संदर्भ भी ज़रूरी है, लेकिन आधा भी ज़रूरी है, 1/4 भी ज़रूरी है, उसको समझना भी ज़रूरी है। तो कैसे संदर्भ से शुरू करके हम 1/2, 1/4, 5, 7, 5⁻⁷ तक जाएंगे, उसके बारे में भी हमें थोड़ा सोचना चाहिए, दैट हाउ विल आवर स्टूडेंट्स बिकम इंडिपेंडेंट ऑफ द कॉन्टेक्स्ट एंड बी एबल टू डील विद मैथमेटिक्स इवेंचुअली, बिकॉज यू केप्ट रेफरिंग टू द फैक्ट कि शुरू में हमें ऐसे शुरू करना चाहिए। सो आई अंडरस्टैंड व्हाट यू ऑल्सो आर सेइंग इज कि बाद में अपन को इससे निकलना भी पड़ेगा, निकलने का भी कोई रास्ता निकालना पड़ेगा, राइट? या निशा, गो अहेड।
हार्डी, मैं इसमें एक ही बात जोड़ना चाहती हूँ कि शुरुआती दौर में जैसे कॉन्क्रीट से एब्स्ट्रैक्ट की तरफ हम जा रहे हैं, वहाँ पे हम संदर्भ से उदाहरण ले रहे हैं, ये बात तो ठीक है। उसके बाद हम 1/4, 1/2 की अवधारणा भी बच्चों को समझा दे रहे हैं, एंड देन वी से दैट वी आर मूविंग ऑन टू ओनली सिंबल्स। लेकिन मुझे लगता है कि एक रेकरिंग प्रोसेस होना चाहिए कि आपने संदर्भों से लिया, आपने उसको सिंबलाइज किया, अब ऐसा नहीं होना चाहिए कि आप अब उसमें ही रहेंगे सिंबल्स की दुनिया में। आपको बच्चों को मदद करनी पड़ेगी कि वो सिंबल से अपने आप कोई ऐसा कॉन्टेक्स्ट से जोड़े, उसमें उस तरह का कॉन्टेक्स्ट में अप्लाई करने की कोशिश करें। सो आई थिंक दैट हैज टू बी अ रेकरिंग और अ साइक्लिकल प्रोसेस, and even at the higher stage of learning, that should be emphasized, because many a times I listen to people and they say that pata nahi we learned limits, we learned these concepts, but we don't know how to apply, what was the use, I have not been applying in my life, and so on. So I think this cycle is important. Even when students have learned or mastered the playing with symbols, coming back to context and rethinking about how does it apply is important. And that's where also I think earlier also I said this point, that on the face of it we may see that these are just symbols and we are playing with them, but if we add a narrative to it, say that the narrative or the description or explanation to it, it becomes more meaningful even for the adult learners. So I don't see at any point we will be able to teach maths only using abstract symbols on the board. You have to accompany with it with a lot of language inputs.
Yeah, I mean, I think you have kind of in one more dimension of the point about mathematization, that relating constantly mathematical ideas to life and life situations is very important to understand those concepts and the relationships that exist. And I think what you are suggesting is that we need to keep going back to life situations and contexts so that you understand the concepts more deeply. And I think that perhaps links to what Arddhendu was also saying about conceptual understanding and simply knowing the procedures of doing mathematics. I think these are both very important ideas. That one, the fact that आपको बार बार वापस जाना पड़ेगा कॉन्टेक्स्ट से जोड़ने के लिए और नए नए तरह से कॉन्टेक्स्ट को जोड़ना पड़ेगा, और दूसरा ये कि जो प्रोसीजर का ज्ञान है वो भी और कंसेप्ट का ज्ञान दोनों को साथ साथ लेके हमें गणित के शिक्षण के बारे में सोचना पड़ेगा. मैं एक बात और पूछना चाहता हूँ आप दोनों से. सी लॉट ऑफ टाइम्स चिल्ड्रन हैव प्रॉब्लम्स विद वर्ड प्रॉब्लम्स. जो इबारती सवाल होते हैं उसको लेके बच्चों को बहुत दिक्कत होती है. तो हमने भाषा और गणित के जुड़ाव के बारे में बात की. आपने ये बात की कि हाउ यू नीड टू गो बैक टू कॉन्टेक्स्ट टू अंडरस्टैंड द कॉन्सेप्ट and the relationship between concepts better. So how do you understand this challenge of giving examples of word problems to students, and how does one address this issue in classrooms? Who will like to begin, Arddhendu or Nisha? Anyone of you?
Okay. I'll share my experience and observations. So basically, it's true that there is a lots of challenges, or there is a lots of, we need to work more on word problem. It's true. But the problem is that हमने कितने समय वर्ड प्रॉब्लम के ऊपर काम किए हैं, या कितने समय बच्चे के साथ कोई भी प्रॉब्लम दे रहे तो इसमें इंटरेक्शन करने के लिए स्पेस ढूंढे. जनरली मेरा ऑब्जर्वेशन है कि हम बच्चे को ज्यादातर एल्गोरिथम रिलेटेड सवाल देते हैं, बट ड्यूरिंग दैट टाइम आल्सो वी कैन डिस्कस. Like we can ask the student to develop that algorithm, the symbol, into a word problem. So two ways. One is we should not only focus on algorithm, we should discuss with the student during the discussion concept. After that, we can also discuss on the word problems, and also we can frame word problems from the students also. बच्चे को भी word problem बनाने के लिए space देना चाहिए. जैसे मैंने बोल रहा हूँ 2+3 इक्वल टू कितना है, बच्चे को पूछेंगे बता देगा. सेम इसको कन्वर्ट कर दीजिए वर्ड प्रॉब्लम में, बस मुश्किल में आ जाए. उसके पीछे जो मेजर कारण है, एक तो कारण है कि बच्चे को जो लैंग्वेज की समझ होना चाहिए. मैं मैथमेटिकल लैंग्वेज को थोड़ी देर के लिए अलग रखता हूँ. जो नेचुरल लैंग्वेज होता है उसमें भी बहुत सारा चैलेंजेस रहता है. आज के सिचुएशन में इंडिया में देखेंगे तो बहुत सारे बच्चे फाउंडेशनल लिटरेसी न्यूमरेसी के नीचे हैं. इसका मतलब पढ़ने लिखने में भी दिक्कत है. पढ़ने लिखने मतलब पढ़ के समझना, कोई भी चीज को पढ़ के समझना. पढ़ के समझेंगे जब तब समझेंगे कि उसको कॉन्टेक्चुअलाइज कर पाएंगे. तो one issue is that they have issue in reading, normal reading. I'm talking about natural reading. Second issue is that scope and exposure. क्लासरूम में जनरली स्कोप एक्सपोजर बहुत कम मिलता है, जिसको बढ़ाना चाहिए. इवन इफ आप डिस्कशन के दौरान बच्चे से पूछना चाहिए. प्रॉब्लम ये है कि मुझे पहले लगता था कि नहीं, मैं पढ़ाता हूँ तो बहुत अच्छे से बच्चे समझते हैं, लेकिन बाद में पता चला कि नहीं, ये नहीं होता है. आप पढ़ाने से नहीं होता है, जब तक वो पढ़ाने वाला उसमें एक्सप्लोर और एक्सपोजर और उसका पीयर लर्निंग नहीं होता है. तो मेरे हिसाब से जब हम बात करें कोई भी कॉन्सेप्ट में, उसके साथ साथ वर्ड प्रॉब्लम चलता है, उसको अलग नहीं करना है. हम हर चीज लिखते हैं तो उसपे बच्चे से पूछना चाहिए कि आप इसका वर्ड प्रॉब्लम बना सकते हैं क्या, इस कॉन्टेक्स्ट क्या है बताओ. एक सवाल लिखा है, सिंबॉलिक फॉर्म में लिखा है, तो उसका कॉन्टेक्स्ट क्या है बताओ. तो बच्चा बता सकता है. एक्सपोजर देना पड़ेगा. मैं नहीं कह रहा हूँ कि एक दिन में हो जाएगा, बट इफ यू प्रोवाइड एक्सपोजर, if you provide a platform where student can interact with each other, they can discuss with each other, then surely they can develop this habit of solving word problems effectively. तो मेरे हिसाब से हमको थोड़ा नेचुरल लैंग्वेज को पढ़ने को लेके काम करना चाहिए. दूसरा जो एक्सपोजर है, बच्चे को सवाल बनाना है वर्ड प्रॉब्लम को लेके, उस पे लिए स्पेस देना है, तो बच्चे कर पाएंगे. थैंक यू.
Nisha, you want to add to this?
Yeah, I would just add as very one or two points here. One is that word problems, I think, are very specific, use very specific kind of language and very specific to mathematics classroom. These are not the general and informal conversations that one would experience in at home, right? So this is specific about a school subject wherein they ask us the questions like, so many bananas the person had and he sold it for so this way of thinking that the word problem requires is not there in the informal conversations that people or children have generally at home. So one is that like Arddhendu said, a lot of examples would help, lot of examples of this way of thinking at a life situation would help. Maybe that they are going several times to buy vegetables or grocery items with their parents, but this kind of conversation has not happened with them. So maybe taking those situation in the classroom, or creating such situation, having a market day in the classroom, and then asking them to create those many kinds of questions. And also from one expression, say 20 multiplied by 5 is equal to 100 is the expression, then how many different kinds of word problems can be created? And what could be more tricky? So for example, I know some my own experience that I was told when I was a child that whenever there is all together in the question, you are supposed to add or you are supposed to multiply. If it is left with, then you are supposed to subtract. But there could be examples. For example, I just wrote one word problem now. In a party, say Satish spent rupees 250, he is left with rupees 100. So how much money did he have when he began the party, and so on. So this could be confusing. People may think that because there is left and all that there, maybe that they have to add and so on. So one is also like Arddhendu is saying, a lot of examples and lot of multiple ways of expressing the same expression. So multiple operations can be thought about for a simple or single expression that can be done. Yeah, Dendu has a point, I think.
Actually, I remember one thing that जनरली ना, जब हम गणित में वर्ड प्रॉब्लम के बारे में बात करते हैं, ये हालांकि टेक्निकली प्रॉब्लम है तो पढ़ाना ऐसा नहीं चाहिए. हमने बहुत सारा एक्शन वर्ब के बारे में बात करते हैं. एक्शन वर्ब इन द सेंस सम लिखा है, टुगेदर लिखा है तो ज्वाइन कर दो, ऐड कर दो. प्रॉब्लम कॉन्टेक्स्ट कुछ अलग है, तो उस वर्ड प्रॉब्लम को पढ़ेंगे तो उसका मायने कुछ अलग है. बट चिल्ड्रन जनरली फाइंड एक्शन वर्ब and based on that she solve problem. That was the strategy taught by the teachers also, some of the teachers also. So that's create one problem. Second is that as said na, in each operation na, in addition, subtraction, multiplication, division, we can create a lots of problem in the sense lots of types of mathematical problem, word problem. So that should be that should be discussed with the students in the classroom. I'm not talking about the by changing the digits. The context changes. Suppose 5 minus 3 equal to what is the remaining part will be there. It is the simplest form, and you can create simple word problems. But suppose 5 minus the space is there, and the result is 2. Then you can also create a word problem on that, and that will be very difficult for the students. So we should exposure. We should provide exposure on different types of word problem based on the algorithm. It is there in the textbook, but not highlighted in that frame. So I think we should work on two things. One is we should, in the teaching process, we should not encourage student to find the action verb without understanding the context and the whole problem. Second is we should provide different type of word problem on the same concept or same operations. So that will also help students to uh, minimize the problem in the word problem. Thank you.
Both Nisha and Arddhendu, there's one question. Both of you have kind of strongly argued for making word problems, making context problems, and getting students to make such problems. There is, Arshia, who's asking, many students struggle in writing problems. So why is it, how important is it to have students make statements? Because there is a struggle in making such statements from children.
See, I also feel that this struggle is not just the struggle of mathematics classroom for those children. It is also the struggle in EVS classroom and the language classrooms. So it is important to work on language for all the children who are struggling to uh, think about word problems or convert the expressions into the word problems. You see, it is not important that they use correct or grammatically correct statements. It's more important to ensure that they are able to express that particular mathematical expression into words applied to the context. So here the focus is not on grammatically correct statements, but on the visualization. So they should be able to at least open up and express how they are visualizing the problem, or draw something and show how they are doing it. Even if they draw, they will have to talk something about what they have drawn. So, and this specific case where children are struggling, we need to work on their language abilities without worrying about grammar and it so on, or spellings.
Arddhendu, there is this question, and you can respond to that as well as this. There is a question which Ajay is asking, that the syllabus is very vast. So how does one deal with all that, what we have been talking about, relating mathematics to the context, and getting students to make verbal problems and develop language, and also ensure that you finish the syllabus. मतलब syllabus भी खत्म करना है और ये सब जो आप कह रहे हैं ये भी करना है, ये कैसे करें?
Okay, so first of all, we should understand as a teacher now. We should understand what is the objective of teaching maths. Because my understanding is that sometimes we miss that objective. That's why we move here and there. In our school now, sometimes I discuss with teacher that don't see a year as the final. Suppose you have class 3, 4, 5, and I am teaching student of class 3, 4, 5. I should have planned for different student as per their level. Suppose some students are confident and they can do, then I should plan for that, and they can solve, they can complete the syllabus. I'm not using the syllabus. They can complete the expected LOs, learning outcome, then you can work with them. But the student who are not at that level, then we should not force them to do everything. We should make a plan for 3 years. That's why in a school, it is expected that all the teachers who are teaching in that school, they should plan for students together. Suppose I am a student who is not very good at mathematics, then it is not necessary that everything will be forced to complete in that year. The syllabus, we should make a plan. Suppose I am expecting that I have to make the concept in a hierarchical manner, and I'll divide into 3 years and work on that, work with the students on those competency on the priority basis. So my understanding is that we should not worry about the syllabus. We should prioritize based on the understanding of the students and work on that, so that they can develop their understanding after. Suppose this year we cannot complete the expected learning outcome, next year they can, because मेरा समझ है कि बच्चे का जो लर्निंग का पेस होता है, जो स्पीड होता है, वो हमेशा फिक्स नहीं रहता है. कभी वो बहुत स्लो चलता है, कभी वो बहुत तेज चलता है, मतलब बहुत तेज में समझ जाता है. तो मेरे हिसाब से हमको टोटलिटी में प्लान करना चाहिए और अलग अलग बच्चे के लिए प्लान करना पड़ेगा. एक प्लान में हर बच्चे को स्कूल में नहीं कर सकते हैं. ये हमको, मैं ये नहीं कह रहा हूँ करना आसान है, ये आसान नहीं है. इट इज नॉट इजी टू प्लान फॉर डिफरेंट लर्निंग लेवल ऑफ स्टूडेंट्स, बट इफ यू वर्क एंड प्लान at least for 2 level of students, that will be effective for that students also, and we will also get a good result in the frame of learning of the students. So multi-level students, we have to plan for multi-level student and work on that basis. And we should not focus on 1 year only. If the student is staying in our school for 5 years, we should plan for the 5 years for that student. Thank you.
निशा, आपको कुछ कहना है इसमें? आपको क्यों लगता है जरूरी है? You want to say something about this?
See, I also feel that if we do not work on the word problem today, and if we say that symbols से तो कर पा रहे हैं, फिर गणित का तो उद्देश्य ही है सिंबल से हो जाएगा, आगे जाके देखिए बच्चों को दिक्कत आती है. शुरुआत में बच्चे नंबर से खेल कर जवाब दे देंगे, पहाड़े लर्न कर लेंगे, लेकिन जैसे वो आगे जाते हैं जहाँ पर उनको ज़्यादा एब्स्ट्रैक्शन की, विजुअलाइजेशन की ज़रूरत होती है, वहाँ वो नहीं कर पाते हैं. फिर कई सारे बच्चों को गणित कठिन लगने लगता है. तो ये जो बेसिक फाउंडेशन है अपना, उसको स्ट्रॉन्ग करने के लिए तो ज़रूरी है कि हम समय लगाएं. हमें समय लगेगा शुरुआती दौर में, लेकिन देखिए इतना भी नहीं लगेगा कि हम इतने पीछे हो जाएंगे सिलेबस से, क्योंकि आप यदि लर्निंग आउटकम्स को देखें तो सिलेबस में क्या है, चौथी तक के गणित में 4 साल को एक स्टेज मानिए, 1 से 4 साल को एक स्टेज मानिए. उस स्टेज में आपको बच्चों को प्लस करना, माइनस करना, अवधारणाएं समझाना और गुणा भाग करना, फ्रैक्शंस, इतना ही पढ़ाना है. ऐसे देखा जाए तो मुझे नहीं लगता कि सिलेबस बहुत है, यदि हम उसको होलिस्टिकली देखें, जैसे कि अर्धेंदु ने कहा. और भाषा पर काम करना, बच्चों की एकदम फाउंडेशनल काम करना, उनकी नींव को मजबूत बनाना जरूरी है. तो इसके लिए समय लगता है तो जरूर लगाइए. It will not be a waste.
So what I understand both of you saying is that if you want students to learn mathematics and become capable of doing mathematics, you need to spend time. You spend time initially, and then they will pick up the pace and they will cover up the rest of it if they start understanding. But if they don't start understanding and you get them to solve problems procedurally, they will forget everything, and then by the time they come to later classes, they will have trouble in understanding even elementary mathematics. So इसलिए अच्छा ये है कि हम शुरू में समय लगा के धैर्य से उनके लेवल के हिसाब से उनको मौका दें समझने का, ताकि वो आगे बढ़ के खुद मैथमेटिक्स सीख पाए. This is what I understand from both of you. There is one more question which that's the last question we will take. Is there any difference between understanding using logic and understanding using context? Or are they the same thing, or what is the relationship?
Arddhendu can add. I'll just begin, Arddhendu.
Yeah.
That ये अब तक जो बात हमने की है उसमें हमने यही कहा है कि संदर्भ जब होगा तब इस तरह का एब्स्ट्रैक्ट थिंकिंग और लॉजिक को डेवलप करने में आसानी होगी. तो ये कॉन्टेक्स्ट और द कॉन्क्रीट इंटरैक्शन with the people, with the objects, actually is foundational for developing further abstraction or logical thinking. ठीक है, लेकिन लॉजिकल ऐसा नहीं होता है कि बच्चे स्कूल में आकर ही लॉजिकल थिंकिंग सीख रहे होते हैं. उसकी बुनियाद शुरू से ही शुरू होती है, जब बच्चे ये देखते हैं कि simple things like if I throw something, it will fall. If I throw it in this angle, they may not be explained to you, but it will hit there. why will it hit there, and all that. They have all kinds of logical questions. For example, stars are there up in the sky, but they never fall down. But if I throw a ball, it falls down. So these are the questions that the children have, and there is no particular output that this is logic now. So it is always in the stages and the phases and the disciplines in which we are applying the logic, right? So I think it is as per the experience, as per the discipline, that we are learning different kinds of logical thinking. So, and as far as language is concerned, even there we do a lot of logical stuff by placing our arguments, by debating, by showing or demonstrating some kind of interrelationships and so on. So I think that is quite a broad question for this session today. But Ardhendu, or you can add, Adi.
Okay. So the question is, as I understand, what is is there any difference between understanding with context and understanding with logic? So first of all, I practical point of view, I think, like teacher says, na, I have used the context and student can form the solve the problem, but when I remove the context, the student cannot solve the problem. So so if this question is a question is prakar ka hai, so I will say that the problem is not the context or logic. The problem is that understanding. The problem is in the understanding. I think the transition, na, we are talking about the transition. So if the child understand the context. So child understand the concept. That's why we have chosen, na? Because as Hadiji says, na, we have to use context which is familiar with the students. आप ऐसा कॉन्टेक्स्ट नहीं लेंगे कि रॉकेट कैसे जाता है, आप लेंगे कि उसके घर के आसपास का, तो उसके अंदर अंडरस्टैंडिंग है कॉन्टेक्स्ट का. दैट्स व्हाई वी अप्लाई फॉर अंडरस्टैंडिंग द कॉन्सेप्ट. And so my understanding is that the transition remains different. That's why it seems that these are two different things. Otherwise, if you are understanding, already the student have the understanding of the concept. That's why we are using to develop the understanding of the concept. And logic is always there in the conceptual understanding. If you are saying understanding, that means I can do it logically. I can do things.
Thank you. So I think there are two ways to look at this question. One is, of course, the fact that context itself needs to be understood logically, and so therefore there is a logic in understanding the context itself, and that is what I understood from what Nisha said. Because when you have a context, it also has its elements which you have to be logically connect. But also the point is that when you do mathematics, sometimes you use what is basically simply mathematical logic, which are linked statements to prove something or to reach some particular answer. I think so. I mean, depending upon the way the word is being used, there may be distinctions that we may have to think about. And as Arddhendu and Nisha both said, maybe we require a more detailed conversation around what is the meaning and implication of this question. But in terms of purposes today, there is context, and the context and language both help in making student logically connect the concepts and the algorithms that are emerging from the methods that we use. So I think in that sense, perhaps we should just use the word context and logic in context both together for the time being, because language, context are both logical. I think we'll stop here. There are other questions which we have not taken, but I think they have been broadly discussed by what Arddhendu and Nisha have said. Thanks to both you and Nisha and Arddhendu for very important points that they have made about the question, and I'm sure that this requires a greater and longer discussion further. But for the moment, thank you both, and thanks to all the listeners who joined in to hear us. Thank you so much.
Thank you,
Thank you,
Hardik.
sir.
Thank
Thank
you,
you,
everyone.
everyone.